Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
resistance, resistance in wires and resistance in circuits. There is a resistance to the flow of an electric current through most conductors. So the resistance in a wire increases as the length of the wire increases or as the thickness of the wire decreases. So the resistance in a long wire is greater than the resistance in a short wire because the electrons collide with more ions as they pass through it. So the relationship between resistance of the length of the wire is proportional. Wires with a larger cross-section have a lower resistance. So this is because electrons have a larger area to flow through, so they will collide with less ions as they pass through. So when a wire is heated, the ions will begin to vibrate and move more quickly. So the more ions vibrate, the more space they take up, so the electrons will collide with more of the ions as they pass through. So if we think about as a bulb gets brighter, its resistance increases. Explain why. The reason why is that the bulb, the longer it's on, it gets hotter, so more ions in the metal vibrate, so more of the electrons collide with the ions, which makes it harder for them to travel down the wire. So the resistance is a measure of how difficult it is for the current to flow through a wire. Right, so resistance is measured in ohms and can be calculated in the following way. So it's always given that voltage is equal to current times resistance. So if we were going to go then and look at this question, so a filament bulb has a current of 0.2 amps running with a potential difference of 5 volts. What is the resistance? So we start off with rearranging the equation to resistance is equal to voltage divided by current. So that would be 5 divided by 0.2, which would give a resistance of 25 ohms. The total resistance of a series circuit is equal to the sum of the individual resistors in it, or components in it. Voltage applied to a series circuit is equal to the sum of the individual voltage drops. So the voltage drop across a resistor or a component in a series circuit is directly proportional to the size of the resistor. So if we look at this, if we've got a voltage of 6 volts and a current of 6 amps, then to work out the voltage, it would just be 6 divided by 6. So the resistance in this circuit would be 1 ohm. If we look at this circuit, so we would have the same again. So we've got 6 volts with a 3 amp of current. So it'd just be 6 divided by 3, which would give a resistance of 2 ohms. The total resistance, like we've said, can be made up by the sum of the individual resistors. So in this example, all it would be is the resistance would be the sum of resistor 1, 2 and 3. So to be 14 plus 8 plus 2, which would give a total resistance of 24 ohms. In a parallel circuit, the net resistance decreases as more components are added because there are more paths for the current to take. So if we look at this question, so student build a circuit shown in the diagram above, calculate the total resistance in the circuit. We'll do that by rearranging our equation, which would give us 12 divided by 1.6, which would be 7.5 ohms of resistance. If we were looking at calculating the resistance of resistor Q, all we're doing is taking the total resistance, which we previously worked out, and we're minusing the resistance from resistor P. So that would be 7.5 minus 3.5, which would give us a resistance of 4 ohms in resistor Q. So one last question. So students set up the electrical circuit shown in the figure below. The ammeter displays a reading of 0.1 amps. Calculate the potential difference across a 45 ohm resistor. So we'd start off, we'd rearrange our equation, which would give us 0.1 times 45, which would mean that we would need a voltage of 4.5. If we're calculating the resistor of the resistor labelled R, that would just be the total resistance in that circuit, which would be 120. So you do 120 minus 105, which means that the resistance for resistor R would be 15 ohms. And if we're stating, or if we're looking to state what happens to the total resistance of a circuit and the current through the circuit when the switch S is closed, the total would decrease, so the current would increase.
Thanks for watching.